so this is going to be number 7 in your TAN packet for section number 3. So, number 7 says, with an average acceleration of negative 0.5 meters per second squared, how long will it take a cyclist to bring a bicycle with initial velocity of positive 13.5 meters per second to a complete stop? So, we have no mention of distance here, so we're going to use our normal acceleration equation of acceleration equals Vf minus Vi over t. We need to make a variables list here on the left-hand side. Each variable gets its own equal sign. So now we have to determine from the information given what goes with each variable. So it says with an average acceleration of negative 0.5 meters per second squared. So I'm going to put that next to acceleration. How long will it take the cyclist to bring the bicycle with an initial velocity of 13.5 meters per second to a complete stop? Complete stop means our final velocity is going to be 0 meters per second. We're trying to figure out how long it takes to come to complete stop, so time is going to be our question mark. So this is where things get a little tricky with the acceleration equation. We want t by itself, right? So we need to get t on the other side by itself. So what I'm going to do is I'm going to multiply both sides by t. Because what I do to one side, I must do to the other. So if I'm trying to get rid of t, I have to multiply it since it's divided, and that's the opposite of division is multiplication. But that also means over here, this now becomes at equals Vf minus Vi. We still don't have t by itself. We need to get acceleration away from it. So we're going to divide both sides by acceleration. These cancel out. Our final equation becomes time equals Vf minus Vi over acceleration. If you're somebody that struggles with algebra, maybe you want to write that on your equation sheet. Again, you only get one equation card. You can use it front and back, but if that's something you think would be beneficial for you, I would write that down if you don't want to do the algebra every single time, or if you struggle with the algebra. Now I just need to plug in my numbers. T equals a Vf, our Vf is 0. Our initial velocity is 13.5 divided by my acceleration, which is negative 0.5 meters per second per second. So I'm going to plug that into my calculator real fast. Negative 13.5 right, because 0 minus 13.5 is negative 13.5, divided by negative 0.5. Our time becomes 27 seconds, which is my final answer. Time does not need a direction. Again, the tricky part about number 7 is you needed to do some algebra in order to get t by itself on one side. All right, that's number 7.